Welcome to our second Wise SCADA lesson. In this lesson, we will examine the SCADA tag structure. Under the tags heading, there is a network that appears as internal and is added by default when a project is first created. Inside this network, there is a device named System. These are the standard Wise SCADA tags. You cannot change these, but you can use them within your project. You can establish your own internal structure by adding a new device here. And you can create tags within it. Or you can add an internal network as a completely new network. You can define tags here in this way as well. In Wise SCADA licensing, internal tags are completely free. You can use as many as you wish. Now, let's create a sample tag application. When we click on New, we first need to select the protocol. I am selecting the Fulmatic TCP Protocol. Depending on the selected protocol, these tables may vary. You can read the details in the program's help pages. First, I am entering the IP address of the PLC to be connected. Currently, there is a PLC running in simulation mode on my computer. Let me show you that as well. Yes, now we will connect to this PLC device. We must create the tags. I have defined two tags with continuously changing values at addresses MD0 and MD4, which I defined in the PLC program. When I press the Connect button, you can see the query times, the sent query, the received response, and the related explanation below. In the table here, the values read from the PLC are visible in the value column. You can ensure writing directly to the PLC side by entering new values in the right section. Let's add one more device to the tree structure on the left. I will explain the topic more clearly this way. I have created two tags here as well. If I click on the top, I see all the tags. Or by clicking only on the device section, I view the tags belonging to that device. When online, the 00 and 11 expressions on the far left show that these are read within the same query packet. It is not very important in the Fulmatic protocol, but in the Modbus protocol, it is important that the addresses are sequential when creating tags. This way, queries are combined to provide faster reading. We can read these addresses via Modbus in the same way. This time, I am adding Modbus TCP from the new section. For the IP address, I am entering the IP address, which is the local address of the simulator again. I am changing the device address to 0. Because in Fulmatic PLCs, the device address is 0. You must enter the address appropriate for your device here. Now let me bring the Fulmatic program back to the screen immediately. We saw that the address of MD0 in the tags is 400,513 and 515. I am entering 400,513 and 400,515 into the address section. I am connecting. Now the structure of transmitted and read data in the table below has changed. We are reading these addresses via the Modbus protocol. Yes, I think the mistake I made was related to the data type. In the PLC, these are defined as 32-bit. Yes, we are seeing the correct values right now. Now let me try to explain why the addresses need to be sequential. I added the same addresses over and over again. And when I connected to the PLC, these were not read in a single query. These became a separate query, and those became a separate query, meaning 3 queries were required to read all the tags here. Therefore, the time extended to the 300 millisecond level. Of course, we can ensure faster reading by entering a lower delay parameter here. But what is more important than this is entering the addresses sequentially. Let's make these addresses sequential now. 417, 419, 421, and 423. Now when we connect, as you can see, all tags were read within the same packet. And our reading speed has increased compared to before. Let's make it 100 milliseconds again. We see the duration at the 100 millisecond level instead of 300 milliseconds. We have explained one of the most common mistakes. Finally, I want to explain the deadband topic. Let's continue with Fulmatic. Let's add two tags again and select their type as real. Let's apply deadband to one of them. Let's make the value 0.1. Yes, now let's connect to the PLC. Actually, let's do this. When I enter a value like 1.123 from the right values column, I should not have used the address present in the PLC in the values section. Because the PLC program is constantly writing data to this address, I am making it a different address. Both should be the same address, both should be the same value. But deadband was applied to one of them. Now when I give the set value, the value inside the PLC appears exactly as is in the one where deadband is not applied. In the one with deadband applied, it changed the value to have 2 digits after the decimal point. When I entered a different value, it made it 1.13 instead of 1.12. Because it rounded the number up due to the 5 in the third decimal place. Deadband must definitely be applied in real, that is, floating point numbers. Because due to its structure, the values in the 4th and 5th digits after the decimal point can change. Very long numerical values may occur on the screen whenever a value changes. Deadband must be applied to limit these. We have come to the end of this lesson. In our next lesson, we will continue with tag topics.